Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a motherboard socket 1700, right? What is this board? Z790 Tomahawk. Very nice. Outputs are the connectivity, Wi-Fi built in, digital audio, all that kind of stuff. Now, what we're gonna do today is we're gonna test a Rework TC, our new addition to IR6500. It only requires 2 wires to be connected to the racks on the left, connected via USB to the computer on which you're connecting to the machine. It should be detected automatically, and it allows you to control the bed. Now the board belongs to one of those a little more flimsy ones. It's not super thin, but it's definitely rather flimsy. So slow preheating is a key. Timing is everything. The profile we're going to be using is going to be Rework TC socket replacement. Over here, as you can see, it has 18 steps. That's not something that you can do on a stock machine. Only Rework Pro has the ability to have this many steps. So we want to preheat the bed like I normally do, but I had to do it manually. So bump it by 5 or 10 degrees every few minutes. It's very labor intensive task. Now Rework TC is supposed to do that for me. So we're gonna start. All temperatures are set to 0 because we're only controlling the bed. Now those steps are no longer going to be skipped. That problem has been fixed. So this temperature is going to be uploaded to Rework TC, and the bed is going to be growing slowly to that temperature. So we're holding for 120 seconds from 50, 60, 70, 80, 90. Then we let it dry. So for 320 seconds, we're holding the temperature of 100 degrees on the board. Now that allows the entire board to heat up. Because yes, it would be better if we had a heater larger than the board. But we also are heating up to relatively high temperatures. You don't necessarily want to heat up the entire board to that temperature, only the area you're working on. But the difference between the temperature of the area you're working on and the rest of the board cannot be too high, otherwise the board is gonna warp in many ways. So we're gonna be sitting on the dry step for a little while. Then we continue ramping. So ramp 5, we get 110, 120, 130, 140, 50, 60, 70. On 160, again, we're stabilizing. So on 160, we're holding for 320 seconds again, allowing the rest of the board to heat up. Now on the sped up footage, you should be able to see how the board slightly warps when the temperature goes up, and it should, as the rest of the board heats up, it should slowly start returning to its original shape. So I'm guessing that until this step we shouldn't have any warping, especially since we're ramping relatively slowly, only 10 degrees per step. Now when I do it on the Rex, I bump by 5 degrees. But it's a different kind of controller that we're going to be using today. After all that, so that's going to be roughly like 40 minutes of preheating. The minimum preheating time that I use is, well, 20-25 minutes, but that's a little bit on the non-safe side. That's a little bit on the fast side. The best results I get is when I preheat for roughly 40-45 minutes. Now, obviously, that adds up to the process time, but since I don't have to do it manually anymore, my Rework TC is going to be taking care of that. That's not a problem. I can just leave the machine, set the timer for, I don't know, 40-45 minutes and just go do something else, right? As soon as the timer starts beeping, I come back and the profile should be starting at that time. And essentially, I only have to be by the machine starting from this step, the top ramp, right? When it reaches 205, then it goes to 215 and it holds for 160 seconds. Now, as you can see, we preheated the bed to 190 degrees and we held it on the ramp 12. held it for 120 seconds. So this is not preheated yet because we want 205 or 210 at the bottom. It kind of also depends. Remember that the temperature at the bottom is extremely important, if not even more important than temperature at the top. Then once we start the actual profile, so we're ramping 0.4 degree per second to 185, that's when we bump the bed by 5 degrees. So the bed is going to start working as well. Then when we hit to, this is a mid step where we pause for 20 seconds on 205, just to stabilize the board a little. That's when we go to all the way to 205. And finally, the final step, once we start ramping with 0.2 degrees per second to 215, that's when we ramp the bed to 210. And that's it. Now we could add another step like wicking, right? And just do 3 degrees and 0 degrees on the top, right? And hold it for say 400 seconds and keep the bed at say 175, right? And that's the time I need for wicking the board to replace the socket. Now I didn't quite think that all the way through, because now I'm thinking once I'm done wicking, right? So usually what I do, I just hit preheat, right? Or long preheat. Once I'm done, once I remove the socket, then I drop the temperature and I do long preheat. But in this case, this is not quite going to work. I would have to disconnect Rework TC and just switch to Rex and put the temperature on Rex. So the Rex is keeping that. So maybe I'll keep this step. We'll see. But after I remove the socket, I will likely just remove all these steps, right? And once I replace the socket, I just run this profile because the bed is already going to be preheated. Or I just add another step in front of it to preheat the bed again to say 205 or 195, and that's when I start the profile. So this is going to be a first run of this version of Rework Pro with this attachment. So I anticipate some problems. So we're not working on a customer device. Well, maybe in a way, it's a friend of mine's board for socket replacement. It has a really good outline. Oh, maybe not really good, but it's got okay outline. It's one of those crappy ones actually that is not, yeah. But I don't want to test it on a customer board the first time. All right, let's get everything set up and let's see how it works. Alrighty, socket is replaced. Now, what is the result? I am super happy with it. Now, I didn't review the footage yet. You're gonna see in the footage whether the socket is dropping slowly when the temperature rises and then returning. That's usually how it looks like. But in this case, I know it didn't sag too much because before wicking, I put the little blob of leaded solder, obviously, and then do the wicking. So once I'm done with the blob, I move the blob to the right, right? And usually when I release it, it just floats because there's flux on the board, so it's slick. So it just floats to the center, and of course it's gonna touch the cups. And once it does, then you have to resolder the cups. Sucks, but it happens. In this case, I put the blob to the right. It did not move an inch and half an inch, even a millimeter. So that's how I know that the board was flat when I removed the socket and when I started wicking. Now, obviously, I started wicking a few seconds after removing, so the board has a few seconds to kind of cool down, so that could prevent it or have it return to its shape, its flatness. But I've never seen that before, only now. Now, the preheating was 45 minutes. The maximum power of the heater was at around 70%. And throughout the process, it was roughly around 55-60%, no more than that. 58, 59, that was the maximum until we reached 150. And then after 150, the distance between the set point and the measured temperature was growing larger and larger. So the power went all the way to roughly 70, 71%. No more than that. And I was thinking, I want to fix that. So I want if there is a difference of say 20 degrees between set point and measured, I wanted to go all the way to 100 degrees. But then I realized that's why the board never warped, because we never blasted it with heat. It was always maximum of 70% on the heater. It still goes to the target temperature, just very slowly. And that's what we want. We want it to be slow. It looks good. It's soldered on. So because there was no warping, I suspect that this is going to be a successful replacement. Just have to clean it, provided that we aligned it properly, but it looks aligned like it was before. I think we're good there. Yeah, I'm pretty sure we're good here. But, you know, there's always that risk that we misaligned it and it's not gonna work in that case. There's always that risk, but in this case, I don't think we messed up the alignment. I didn't see if it pulled to the position, but it is holding nicely. It is holding very well. So, to sum up, we have perfect bed controller, or perfect control over the bed temperature. So obviously I was overseeing the process, watching the power going up and down, watching the overshoot, and all that kind of stuff. But at this point, I'm just gonna do like maybe a couple more boards as a test, just watching the process. And the next board I'm doing, I'm just gonna set it for 45 minutes, and I'm just gonna leave and come back in 45 minutes when the board is already preheated and everything is ready to be worked on. It's a lot easier because the blob stays where you put it. It doesn't run into the center of the board. The flux, because there's a hole in the board, right, in the very center here. So if there is bulging down, it creates kind of a funnel, and all that flux that you put on the board, it eventually makes it to that hole and drops to the heater, and it smells. It's not a bad smell, but then you have to clean the heater. It takes a lot of effort to clean the heater. In this case, nothing. You see the around the hole, it's clean. It's clean around the hole. You can't really see that very well here, but just, well, maybe you can see it here now, right? It's completely clean around the hole. So no problems there, nothing on the heater at the bottom, not a drop of flux, because the board was perfectly flat. Now, one thing that I forgot, and I forgot to tighten these, right? So the board was a little lower than usual, because the arms were kind of sagging down. But that's fine. It didn't interfere with the process. It doesn't really make any difference. It's perfectly fine. And now the thermocouple was a little bit close to the hole. I couldn't fix it during the process. I figured let's just leave it like that. The discrepancy between Rex and our controller was up to 15 degrees at times. At certain temperatures, it was like a couple degrees of difference. In others, it was the difference of even up to like 15 degrees, 10, maybe 12 degrees, something like that. Now, that probably is related to where my thermocouple was closer to the hole. The Rex's thermocouple was closer to the center. So that's probably where the difference comes from. So the temperatures we were reading throughout the process, they're probably a little bit lower than actual temperatures in the center over here. Most likely, but as I said, with bed the temperature control, you don't have to be that precise. It doesn't really matter whether, you know, if you're 5 degrees off or 10 degrees off. It's not that big of an issue. The top heater, sure, but the bed should be fine. Everything went really well. I'm really happy with this. Now there are a few quirks I still need to figure out for the process. So certain steps were finishing before they were supposed to finish, so I had to start the machine manually. I have a fix for that, or I have an idea of the fix for that. I also want the preheating to work like it did before with the external controller, which it doesn't at the moment. So there are a few things that I still need to figure out. So this version of Rework Pro is not released yet. However, the repository is released. You can build it, upload it to whatever board you want to upload it to, and have it ready as soon as the Rework Pro is released that supports this controller. I might, if I confirm that there are no bugs preventing you from using Rework Pro, that there are no, you know, issues with it, I might release it as an early version release. So there might be some problems still, but overall it'll work like it did over here. So stay tuned for that. But I call it a success, and I think that was the last issue that I had to figure out with this procedure. I mean, alignment is still kind of an issue, but I'm getting a hang of it. But warping was the last problem that would prevent me from fixing some of the boards. I think with this solution, we can now bring the success rate of this process all the way to 100%, which would be awesome, but I would be happy with 85%, honestly. 85, maybe 90. So out of 10 boards, I want 9 to work, 1 to not work. Alrighty, hope you guys found this useful. Thank you very much for watching, and I shall see you guys in the next one.